Hello there. Let us look at the C control structures, lecture 6. So let us put a task now. The task is to find Armstrong numbers between 1 and n. These exercises thus we are doing to understand the control structures better. That's why I'm using this example. So we have so what is an Armstrong number? An Armstrong number is one where number is equal to sum of cubes of individual digits. Of its individual digits. So what's the meaning of that? For example, if you take 1, it only has one digit. So cube of 1 is equal to 1. So 1 can be an Armstrong number. Yeah. So similarly, let us maybe 155, 153. Let us see if 153 is an Armstrong number. This is 1 cube plus 125 plus 27, right? So 153 is an Armstrong number. Because I'm talking about cube of is equal to cube of 1 plus cube of 5 plus cube of 3, which is nothing but 1 plus 125 plus 27 is equal to 153. Okay, so that's what it means. First, as usual, we will read the value. N is equal to input is equal to scanf percentage d and of n. Okay, so we'll print the value of n also. Given input n is percentage d, which is nothing but n. Okay, let's take Armstrong number dot d. So we go to the retry gcc minus op n dot c. So I have to declare n. Okay, so if I give 5, it is 5. So we are getting our input properly. So before that, we should write a function which will find the we'll find the power of a function, say int comma m comma n, which returns m to the power of n. So this is a function that we will write. So I'll have int power. I'll declare a prototype int comma int. Now if you look at this code, so first let me write the power function. Int power is, I'll take int say m comma int n. So we will have one result that is equal to 1. So here what we are doing is we are multiplying m n times. That's what it actually means. So while my n remains greater than or equal to 1, okay, so let me do this. My result will be equal to result into the value of m. Okay, then I'll decrement the value of n equal to n minus 1. So after everything is done, I'll return the result. Just for understanding, let us look at cube of is percentage d. We'll call the result function power function, which will return the result. So I say n comma 3. Let us compile this. So now if I run this code, so let me take cube of 3, which is 27. If I take cube of 5, which is 125. If I take cube of say 7, it is 343. So our power function is working fine. Right now I have to first write logic for extracting the digits from n, if at all I give n. So for that, I'll create a temporary variable to start with. I need some more variables which I'll take later. So my temp will be now equal to n, whatever is the value of n. What I'll do is while my temp remains greater than 0, I have the logic. So first I'll extract the individual digits and add it to the sum. So my sum will be equal to 0. I will define my int sum is equal to 0. Okay, so my sum will now be equal to, simple logic, sum will now be equal to sum is equal to sum plus temp mod 10. So this is going to give me the digits from right to left, right? Okay, so I take individual digits and that I will pass it to my power function. So this is my first digit and I want to find the cube of that. Okay, so this is what it is. Then I'll say temp equal to temp div 10. I'll move to the next digit. That's what it means. Right, so in the end I should be able to get the result. Okay, so I'll say, and then I will also have so it generates the takes that number and generates what is called the so I'll put one more temp, then one more condition for say I is equal to 1, I remaining less than or equal to n, I plus plus. So this is my, for I have to find an Armstrong numbers between 1 and n, right? So keep this here, then and take this out. For every temp I need to do this. So maybe I'll say this is my I. For every temp my sum will be 0. So after I come out, I'll display the Armstrong number. Okay. Printf slash n, the Armstrong numbers from 1 to percentage %d are slash n. So that's my n. Okay, so I'll also have one variable called int I. Okay, hopefully this should work. So I'll have printf percentage %d space, and if at all that is my number, that will be my sum. I have to put a condition here. So not sum, my I. So if my I is equal to sum, then I will print that. Else I'll simply skip. We'll go to the next one. That's what. So let me save this first. And then compile this. So we have some issue with the for loop. I plus plus. So looks to be okay. So let me take OP. I'll give 1. So the cube of 1 is 1. The Armstrong 1 are 1 itself. Let me see if I have an Armstrong number from 1 to 100. Okay. It is not showing anything here. Maybe 1 to 200. 153 is 1. Yeah. So 153 is one more Armstrong number that we have, right? So if you now give say n equal to 3, I'm sorry, it's not n equal to 3. I'll give n equal to, say if I have one more Armstrong within 1500, if I have one more Armstrong number, yeah, there are 4 or 5 Armstrong numbers. 370. Let's check whether it is 343 plus 27, so that is 370, 371, etc. Okay, so see, this is what we're looking at each of the cubes. So these are our Armstrong numbers. Now if I give n equal to 5, so let us see how many numbers are there between n and 1000. Same numbers. So n and 10,000, same numbers. 1 lakh, 2, 3, 4, 5. So up to 1 lakh we only have 4 Armstrong numbers. So that's a, see the property. 1, 2, 6. So let me give 10 lakhs. Okay. No, we're not lucky. I'm giving 7 zeros now. No, now it's taking time. If you see 7 zeros, then let me give eighth zero as well. See, now it will take time. It's taking time because the time complexity just goes for a toss. So we do not have anything between 1 and so how many zeros I have given? 8 zeros. So let me give 9 zeros. I think we will have a problem with the size of the integer. So it's going to take time, right? So now we know that we can only generate Armstrong numbers from 1 to whatever 7 zeros, right? Afterwards it is going to grow exponentially. It's going to take a lot of time. Of course there are a lot of other techniques to do that. We just wanted to demonstrate how to extract individual digits from a number and how to operate upon in this case we looked at the properties of an Armstrong number. Okay, so we terminate this. Hope that you understood this next in the subsequent lectures. Thank you very much.